Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're joining us on YouTube, you can just use the live chat function wherever it happens to be on your screen on the device that you're using. And I will get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. It's had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I worked at a dealership, and over time, I guess just became the diag guy in the shop. Always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So enough about me. Let's talk about what we're going to talk about tonight. So today, I'm in the Northern Hemisphere, and I think the majority of you are too, but I know there's quite a few people that watch from, like, say, Australia and such. But for the Northern Hemisphere of the Earth, it is getting to be air conditioning season. I know those of you down in southern United States, it's been warm for a while, but up here where I'm at, it's getting warmer. So that means people are starting to think about air conditioning. So we figured we'd do an air condition operation and testing class today, just to kind of give you a little refresher course, I guess. So we're going to talk through the different components and what they do, and the differences that we have throughout the different types of oil and refrigerant and things. You're going to kind of high level, but we'll get into some things. So the different components, of course, of the compressor, and different kind of clutches on those as well we'll talk about, and the different kinds of oil, as I said already. The evaporator, the condenser, receiver dryer, expansion valve, and pressure switches. We'll talk about all of those different components on a standard air conditioning system that most vehicles have out there. So first off, the compressor. So the compressor, the majority that you're going to find out there will be belt driven, because of the majority of vehicles that's been around the longest. Hybrid and electric vehicles, though, are electric, and they use a high voltage, could be 300 plus volts to turn the compressor, and it doesn't use a belt at all. So hybrid vehicles, it's so it doesn't drag down the motor with extra load on the motor. And of course, EVs, because they don't have a gas engine, so it just powers right off the battery pack in both of those cases. Belt driven uses an electromagnetic clutch. It can be tested with a scanner or component testing, or both. So I can function it with my scanner and also see whether or not I have voltage going to and from that clutch as well. And it can be either a fixed or a variable displacement compressor. So we'll talk a little bit more about what that means in a second. But on the variable displacement compressors, which are a newer design that are belt driven, they may not use a clutch either. They may just cycle themselves open to close instead of turning the clutch on and off, which also saves on drag on the engine as well. So that doesn't have that big click clunk to turn on to drag down that engine fairly instantaneously. So generally speaking, there's a few different designs of compressors. Probably the more common one's going to be one with a plate. So we have either a wobble plate style or a swatch plate style. So you see we have the charging ports, intake and discharge valves, the cylinder head here, and it has these pistons that float around on this plate that wobbles. And as it does, it kind of acts like a crankshaft. If you're thinking about a straight line engine, it does the same type of thing. It just kind of wobbles around and it's pushing it in and out. We actually got an animation here in a minute. But as the piston comes in, we get low pressure vapor. As it compresses, then we get a high pressure vapor that comes out the other side. So low pressure comes in, compresses it, presses it out the other side. So here's just an example. I think this was an animation here, or a video of how it works. So there's a swatch plate compressor, and that's how that works. It pushes the pistons up and down, and then as it does so, the plate itself moves, and then it pushes the plates. The plate, as you can see, the plates kind of ride on that or the pistons kind of ride on that plate as it spins around. It's kind of like a bearing type look there. So that's a Swatch plate style, and the plate itself kind of moves around like that. Oh, there we go again. All right, and then a wobble plate compressor has a wobbly shaped type plate, which is a little bit different. And then we have the low pressure comes in, and see we have these springs here as well. So it allows some of that pressure to go in, and then it compresses it. And then there's another ball and check there, and it goes out to high pressure. So a couple different ways that you can go about it between the Swatch plate and the wobble plate there. And then we also have the variable displacement compressor, which what it does is it has this control valve here, and it changes the angle of that wobble plate in there. So you can see it's kind of on a cam system. It's got a rod that pushes it in and out. So if we push it all the way over, we get a much higher rocking back and forth. And if it comes back, we get a much lower rocking back and forth. So less, it's moving less. So we have less displacement in that case. On the large displacement, the pistons are moving very far. Larger displacement, displacing more air. So that is the difference between the two different styles on that variable displacement. So it changes based on this valve. It can control this rod with pressure, and that tells the plate what angle to use, which changes the displacement of the compressor. And it can change based on demand of the vehicle. And then if we talk about electric vehicles, we have the electric compressor as well. So that is a refrigerant comes in, and we use just a DC motor in there to spin the scroll here. So that's kind of a scroll type where it's got the looks like a shell kind of wrapping around in on itself, and as it gets closer and closer, the pressure increases as it goes through the scroll on the compressor there. So we got the DC motor to do that. Refrigerant comes in here, also helps keep it cool a little bit, and allows it to spin and compress. So speaking of compressors and oils and such, we need to also be concerned with refrigerant types as well. So if you were around for a while ago, we had R12 up until about 1994. So that was the original refrigerant pretty much back throughout the 80s. And then 1994, they decided to change to R134A because of that ozone layer, and they wanted to help repair that hole, so it's less detrimental to that. But then they also figured out that there's some problems with 134A as well, and wanted to get something a little bit more efficient, so they came out with 1234YF, which started being used in production cars in 2012. So it's been in use 10 years now, 10 years through current. It's fairly similar, I guess, between 134 and 1234 as far as some of the properties. You want to use this takes a different oil as well, but it is mildly flammable. I guess is what I'm trying to get to. So not necessarily ideal. It's going to be mildly flammable. It's more flammable than 134. Mercedes was experimenting with an R744 in a couple of their cars. They instead of going to the 1234 because of the flammability, but as far as I can tell, they've gone back to the 1234YF as well. There are others perhaps coming down the pike. I've heard inklings of people talking about it, but I don't think there's anything really set in stone at the moment for anything to replace 1234YF. So that's kind of your standard nowadays as to what you're going to use. You can use it, you can get it on a much lesser charge. So we have 4 different types of compressors in vehicles. So we have the R134A belt-driven compressors, which, as we said, that's the vast majority of the market because they've been around the longest. We could convert the R12s to the 134s. I remember doing that back in the day. And then they were still able to use the same type of compressor and such. So there's tons of those out there. And then we have the electrically driven compressors, and they also use R134, but on those compressors, you need to use a different oil because the oil, the PAG oil that you use in 134, it conducts electricity. So you don't want anything electrically conductive running around in a hybrid or electric vehicle. So they switch to this different oil, the ND oil. And then they have R1234YF belt-driven compressors. from 2012, 2013 Cadillac on up. And that uses a different oil too. And then we also have the 1234YF over here on the electric vehicles, which uses the ND oil. So we have two different types of oils, two different types of refrigerants. We want to have no contamination between the refrigerants. On these two, we don't want to have any oil contamination between the two. And same down here, we don't want to have any oil contamination between those two either. So a couple different ways you can go about that. You can either use a couple different machines, or we do have a machine, I know, that does all of these. It does 134 and 1234. And then you just change the oil injection with a different oil injector. So there is that. It's a Cool Care Dual, Cooler Tech Dual. Yeah, it's one of those. It's a dual unit. It does 134 and 1234. And then you can change the oil as well. Air conditioner machines are not my department, so they don't train me on those. But they are available out there. I can talk to your Snap-on rep if you want, if you're interested in covering all the vehicles with one machine instead of having to do multiple machines. They're definitely worth it. All right, now let's talk about more components. So we had the compressor and the oil and the refrigerant. Now let's talk about the evaporator. So that's the part that's in the passenger compartment. When the warm interior air or warmer interior air blows over the fins, we have a liquid going in at low pressure. And then as it goes, it acts like a radiator, removes the heat of the air, and then the liquid turns into vapor. So it evaporates the refrigerant liquid into a vapor. Usually it's located in the heater box near the heater core. So usually they're in the same basic area of the vehicle, kind of in the middle, where the blower box is and all that. So that's why it's called an evaporator, because it evaporates the liquid up to a vapor inside. And then we have the condenser, which does kind of the opposite. So it takes the high pressure vapor, and then it cools off that high pressure vapor, it condenses it down to a liquid. So that's why we get the condenser. So evaporator takes a liquid, evaporates it off into a vapor. And then we have the high pressure vapor go into the condenser, and then it gets condensed down into a liquid. So you know, if we go to a vapor to a liquid, that's condensing, and liquid to a solid, that's more condensing. So, and that's almost always in the engine compartment. Ambient air feeds it, fan cools it. And then, as you said, it condenses into a liquid. Usually it's mounted right next to the radiator. I'm sure you've probably seen those before as well. So it's right up front. Oftentimes they'll have their own fan too. So you might have dual fans on a vehicle, but one of them's for the radiator, one of them's for the condenser. Some vehicles use both for both, but there are oftentimes separate fans. Then we have the receiver dryer. Now I know there's other versions of these, like the orifice tubes and things like that, but that's really on the older R12 system, so we're not going to get into those today. Well, the receiver dryer, that filters the refrigerant. So if there's any impurities in there, it tries to filter them out. There's a filter in here. There's also desiccant, which helps to remove any water that might be in the system. So you could get water in the system a few different ways. This also should be changed out anytime the system is open. So if I open it up and introduce air, ambient air into the system, there's going to be humidity in that air. There's going to be water vapor in that air. So it is usually recommended to be changed at the time when I do any other sort of AC work as well. And then we have the expansion valve. So as I said, there's some older technology before this for R12. We're not going to cover that either. We'll cover the expansion valve. So it steps down the pressure before it enters the evaporator. So we don't want high pressure vapor going into the evaporator. So it uses a diaphragm and a sensing element to kind of bleed off some pressure. When high pressure comes in, we got the little orifice that meters it, and then it allows low pressure liquid out. So high pressure liquid in, low pressure liquid out, and then a low pressure vapor from the evaporator goes out, and then it goes out as a low pressure vapor to the compressor. So it comes in as high due to this metering orifice and the ball there. The liquid goes down to a lower pressure, and that's how it drops the pressure. And the outlet pressure, in turn, helps regulate the inlet pressure with the sensing element and diaphragm. Also, I don't know about every manufacturer, but it could be a pretty common failure point, these expansion valves. I know Subaru's had terrible luck with these. It's a leak point because there's a bunch of O-rings there, and it also can get stuck. And if it gets stuck, then you could have pressure sticking on either side, and you could have a vacuum on the other side. So if that orifice ball gets stuck, gets gummed up, it could be a good failure point right there as well. So I know I changed a lot of those back in my Subaru days. I don't know about other manufacturers, but I'd imagine just due to the design, that's probably just the way it is across the industry. So oftentimes when we found we had problems in there, it was the valve, expansion valve, or expansion block could be called. And then we have pressure switches. So pressures are on. Pressure switches are on-off switches, so they're on or off dependent on the pressure. They could be separate, high, low, or medium, or all three in a combination switch as well. So in this case, we have power, and then it goes to the compressor clutch. So the power comes in when the switch turns on, the contacts close, and then it makes a complete circuit, and it turns on the compressor in this case. So if it's high pressure, it's low pressure. Depending on what it's measuring and what it's sensing, will command the compressor clutch on or off. Or on newer ones, it's going to be a sensor input to the computer, and the computer will decide what to do, especially on those variable displacement ones. It's going to be a PID, and it's going to be an input. It'll still have voltages, but it's not directly connected to the clutch because some of those don't have clutches. So it's just more of an input to see what the pressure is doing as well. All right, so now that we have all of the components covered, at least the majority of the components, we have a little case study here. It was brought up by my friend Nathan, who's down in Dallas, Texas, and he found this 2014 Chrysler 300, and the customer complaint was on hot days, 90 degrees and up, which is like pretty much any day in Dallas. The AC doesn't work as well as it used to. The vehicle's got 58,000 miles, and also a note: the AC has been serviced recently at a discount store auto center. So do with that information what you will. So we need to figure out why this air conditioner is not blowing cold enough. Right? So we need to first figure out, we need to verify the customer's complaint that it is in fact not blowing cold enough. And we should probably check the pressures too, right? So we'll check the pressures and the vent temperatures first. So it's 80 degrees in the shop today, at this day, and it's 45 degrees at the vent. It's kind of close. I mean, it's not 100% where we want it. Usually, rule of thumb, from what I've been told, is about 40 degrees. If we can drop it by about ambient by about 40 degrees, you're doing good. So low pressure is 60 psi, high pressure is 230 psi, is what we're seeing there. So 80 to 45, that's 35-degree drop. That's close. It's on the edge. And then low pressure and high pressure, well, I don't know what the pressure is supposed to be. Usually, it's pretty close to ambient there, right? So let's see. Well, let's look at the chart. So on the chart, it says on this temperature chart on this vehicle, if the ambient temperature is 80 degrees, low pressure gauge should be 40 to 50 psi. High pressure gauge should be 175 to 210 psi. So 60 psi is 10 more than we need there. And then 210 to 230, that's 20 more right there. So we definitely have over pressure in this system. So what's the problem? Let's look at a little flow chart here, a little diagnostic flow chart, or a little chart anyways. So if the low side is high and the high side is high, which is the case, could be either of these two things. If both are high and the temp is warm, it's an overcharge. If both sides are high and there's some cool, it's not quite there, it's either air in the system or it's an overcharge. All right, so either way, we're looking at probably maybe an overcharge. If anything, could be air in the system. And then we can see the other conditions too. If both of them are low and it's warm, expansion valve stuck closed, that could be a problem. Or if it's tube plug, high side restriction, compressor, etc. So in this case, high, and some cool is what we're looking at. So it's high, some cool, air in system or overcharge, because if we look at this chart, the ambient temperature chart, at 80 degrees ambient and 45 degrees out of the vent, that is just at the tippity top of what normal is. And then you can see as we get over 100 degrees, it goes higher. But in this range, we should be lower than this. We're like right at the very top of that range, right? If we cool down even 5 more degrees, we'd be right in the middle of normal. So 45 degrees of the vent, some cool, so it is a little bit cool, but it's not cool enough. Air in system or overcharge. All right. So speaking of overcharging, this system on this vehicle is a critical, what we call a critical charge system. So a lot of your newer vehicles have what we call this critical charge, and it's when they carry 1.5 pounds or less of refrigerant. We have to be more exact than ever before. Now, as far as our machines, we're 98% accurate with the weight. Other machines on the market are 95%. That gives us a 2% room for error, gives the other side 5% room for error. That gives us plus or minus 1% accuracy, and theirs is plus or minus 2.5% accuracy. So plus or minus less than 1/4 of an ounce is the difference between that. Less than 1/4 of an ounce, that's not much. Or over 1/2 an ounce of 0.6 an ounce in the other. So modern vehicles call for much more accuracy when it comes to the quantity of refrigerant to be charged into the AC system. A deviation of plus or minus 15 grams is commonly considered tolerable. So 15 grams in that case is 1/2 an ounce. So that's a little more than tolerable, and that's well within where you would consider tolerable. That plus or minus 15 grams was 1/2 an ounce. So if they're a little over 1/2 an ounce, we're half of that, half of the half. So we also noted that the AC has been serviced recently at discount auto store centers or discount store auto centers. So maybe they overcharged it. Maybe they thought they charged it correctly and they just didn't have accurate enough equipment to measure on a critical charge vehicle. Could be either way. So maybe are we starting to come to a conclusion here? If we know the pressure's too high and we know the possibility of an overcharge and we know that the critical charge system could be a problem with just the equipment. Maybe they did everything right, but the equipment wasn't within enough of a tolerance where it could be. Also note, remember how we said it was serviced at that discount chain, but they didn't go back to the discount chain with the problem. They came to this shop. So that's another thing you want to take into consideration too. Those are those awful never comebacks. All right, you get the comebacks, which aren't too good to start with, but then you have the never comebacks that go somewhere else. All right, so this is a case of that as well, a never comeback. So step one, let's do a complete evac and recharge and then retest. Now we also need to know what kind of refrigerant it has in it, because 2014 on this Chrysler, they started using it on the 300 depending on what it had in there for an engine. So 2014 to 2016, it could depend depending on the engine. And then of course 17, everybody was good, everybody was there. So how do I know that? Well, you probably want to check your repair information. So in this case, I got a 2017 Ram here listed. We could have a 5.7 with 1.234. We could have a 5.7 with 134. And then we have our capacities, not a huge difference. 0.06 of a pound between the two. And you also want to see the compressor label. That's the main thing. You want to check that compressor label to make sure it does have 1.234 or 134A. 1.234 is 1.56, 1.5 there. On a Challenger, Chevy Silverado could be either or. And on this Ford, it was R1234 on a 2017 Ford. By 2017, about half the manufacturers had 1.234 in their systems. So some recent changes, and we've already alluded to these a little bit throughout the presentation. But in 2010, the Prius switched to an electric motor compressor. And those electric compressors require vehicle-specific oils because PAG oil is in an electrical system is an electrocution risk. And if you get PAG oil in a hybrid vehicle or an electric vehicle, you want to replace the whole system. It would be recommended because it can conduct electricity, and that's not a good thing. 2013 Cadillac Xts was the first U.S. model of 1.234, a more environmentally friendly refrigerant, though mildly flammable. Mobile Air Conditioning Society estimated that 48% of 2017 model year vehicles have 1.234YF, and of course it's even more now because R134A was banned starting with 2021 model year. So that was last year. So we're in 2022 model year, so they all should have 1.234YF in there. And if half the vehicles are 5 years old, they're all coming out of warranty if it was covered under their 5-year warranty. You're going to be seeing them if you haven't seen them already, that 1.234. So you got to get ready for that. Special equipment, special oil, all that. We talked about this before, how we want to have no refrigerant contamination between the two refrigerants, and then no oil contamination between the non-electric and the electric vehicles. So according to this, if I'm doing 134A, it's going to be 1.5 pounds on this car. And then if I'm doing 1, 2, 3, 4 YF, it's going to be 1.56 pounds on this car. And in this case, under hood says 1, 2, 3, 4 YF, 470 plus or minus 30 grams. So in this case, 1, 2, 3, 4 YF. So it's got to be real close on the charge there. So they evac recharge with the proper amount of refrigerant, accurate amount, and then they double checked it again. So you obviously want to retest after you're done to make sure that your results are where they need to be. 42 psi, 185 psi. So at 80 degrees, that's on the low end, 40 to 50, and then that's pretty much right smack dab in the middle there for the high side. So that's in good shape with the pressures being 80 degrees in the shop. So that's good. And then doing that, it's now 42 degrees at the vent, which is about halfway up there. So that is much more well in that normal range. We're bringing that down. So on hot days, AC doesn't work as well as it used to. They also had another problem in this car as well, though, because this has dual AC. Could be an air distribution problem, too. So they wanted to check and double check that as well. So they did say that maybe it's a little warmer on one side than the other, even when it's supposed to sync. So it could be a blend door problem. Now, if you watch the HVAC class, then you would, we talk about that. But what they did is they went in the HVAC system. They went under system tests in their scanner. You can do the AC request, or you can do a door actuator position. So we can move them back and forth, and we can do an actuator recalibration as well. So that's what they did. Moves all the HVAC doors to their full travel limits to determine the travel span of each individual door. You need to recalibrate every time you do any work on the system or replace any components on the system. Calibration test completed and passed. And then, of course, how else can we do it? We can verify it by using thermal imaging as well. So if I shoot it at the blend doors or at the vents, and then both vents are coming out the same temperature, then we know we have that problem solved as well. So a couple different things we can do. So once they've done that and they verified that it was working, repair's done, good to go. So that kind of covers a few different topics that we were talking about throughout that presentation with that. So let's go live on the tool now, talk about a couple different things we can do with the HVAC system. First thing I'd like to do is the 2018 Chrysler 300, so a little bit newer than the one we talked about in the case study. I'm going to go look in guided component tests, actually, because there are some guided component tests in here. So if you're not familiar with guided component tests, it's available on all of the Snap-on scan tools with a scope inside, and they give you a ton of information on that. So we have the HVAC system here, and you can see we got the clutch relay, so that'll allow us to test the clutch, the relay, and then the clutch itself, and then the compressor solenoid, high pressure sensor, the air conditioning module itself, ambient air temperature, blower motor relay, evaporator temperature sensor, blower motor resistor, cabin air, a bunch of things on this 2018. Clutch relay, for example, if I wanted to make sure the voltage is flowing through through the relay, I check pin 30 and ground, you should have voltage, and then should have voltage there as well. Gives us a little information. We go to component information, provides voltage to the AC clutch, relay coil supply voltage to pin 86. Pin 85 is grounded by the PCM when AC is commanded on. Pin 30 is fused battery, with pin 87, the relay output to the clutch. And then we can check it inside the power distribution center, right side of the engine compartment. Let's see. So the clutch itself, we can go in there. We can do a DC voltage test and make sure it's getting battery with the AC commanded on. We can check the resistance, should be 4.9 to 5.3 ohms through either side of going through the coil. Should be 4.9 to 5.3 ohms in that case. And then we can also current ramp this as well. So we should be able to see a current ramp down here at the bottom. Yeah. So as soon as the clutch is engaged, you should see a max of 3.1 to 4 amps, and then it'll drop to maintain a steady value. So you should see a spike when it first clicks, and then it'll drop off and just kind of level off there. So a bunch of different tests that you can do. Many vehicles have the HVAC system covered in the guided component test. So if you have one of those tools that has a guided component test, that would not be a bad way to go. Let's go into scanner and check the scanner side as well. It's going to go through starting a security link session. Oops, I hit the wrong button, but that's okay. I'm going to back that up. Let me continue. There we go. All right, so it's going to unlock my secure vehicle gateway, and there is all of my systems right So if I go down a little bit, we got our HVAC system, so we can go right in there. Okay, so we have codes, clear codes, data, of course, functional tests. Functional tests, we have AC request on or off, AC select, EBL status, front blower speed, good for diagnosing the blower, motor itself, mode actuator positions on the main and left, recirc door, actuator positions. Miscellaneous functions, we got ECU information, and then we have system tests in here as well, which is that actuator recalibration. So it cycles through all the actuators to run them to the ends of their travel to figure out, well, where's the max and minimum on these doors. Oops, went backwards. There we go. And back in the HVAC system again. And then data. So let's see what we got for some data in here as well. So lots of things: battery voltage, evap, temperature targets, front HVAC. Let's see, ambient light sensors, mode door positions, twilight sensor as well, vehicle speed, recirc motors, blower fan speeds again. Let's see, recirc actuator span. So a bunch of different AC type on-off requests. Don't pay attention to all this flashing on the screen. This is just demo data, but that's the type of things you would see, different temperatures and voltages. And then you could actuate the compressor clutch on and off while you're testing it with the scope as well. So that's helpful with that. So that's fairly standard. And what you're going to find out there for scan tool functions, there's not a ton of functions you can do just because most systems, it's going to blend doors and blower motors and clutches and things like that. And then we can test it the other way with the other with the scope as well. Also want to look at this one. This is an electric vehicle. So this is the Kona Electric. We talked about this a couple weeks ago when we went through electric vehicles. And I'll just show you a couple differences in here. Let's see, Kona EV. There we go. Danger, high voltage batteries. Be careful. So you can come down here and we have HVAC, auto AC, and the functional tests. They have engine off tests and engine running tests. So engine off tests. Oh, I guess we need engine running tests. But the engine doesn't have an engine. There we go. That's why I got an error. Should have practiced this a little more. Data stream, though, on the electric vehicle. It's going to give us pretty much all the same stuff. So if you think about an electric vehicle, it's just a gas vehicle with an electric motor for all intents and purposes. So it's going to have the same type of HVAC system inside. But as far as the refrigerant, with like refrigerant temp sensors, different valves in there as well, battery cooling valve, evaporator, refrigerant pressures and temperatures you can find through there. And then I think I also wanted to do the guided component test. I think that's what I wanted in there. And for guided component tests on this as well, there's HVAC. And then we have the different blend door actuators, the pressure sensors, blower motors itself, evap temp sensor. So all of these things have the different pressure sensors in there as well. ECM receives pressure signal from the AC high pressure side, and the AC pressure sensor input indicates how much load is the compressor, and is one of the factors using the ECM to determine the idle air control position with the idle speed as well. So it gives you your pin assignments there, your wire colors, and things of that nature. All right, so that is my time. Hopefully, we've got a few tips and tricks on AC systems, how they work a little bit better, a little bit more knowledge on how they work better, and how we might be able to diagnose them a little bit easier. And we also need to make sure that we're not contaminating between refrigerants and between oils on that as well. So next week is the last of our 5 new classes, and it is motorcycle diagnostics. We're going to talk about how am I going to walk through diagnosing a motorcycle versus diagnosing an automobile. It's actually very similar if you think about it. So we'll walk through a couple of different things with that, a lot of different things that we're going to see in the scan tool as well for capabilities with that. So if you're interested, definitely check it out. 6 and 9 Eastern. You'll go to snapon.com/OT, register on Zoom. 6 p.m. Eastern goes to YouTube. So if you're watching on YouTube right now, please make sure you're subscribed. Please make sure you thumbs up and give it a hit that bell on the subscribe button as well. So that way you'll know next time we go live. And that is youtube.com/Snap-on Diagnostics. If you're not on YouTube and you want to watch it there. Also at 9 p.m. Eastern, we go live to my Facebook page. So it's facebook.com/SnapOnJason, all one word, no dash in the Snap-on. So you can check it out 9 p.m. on Facebook as well if you wish. As far as previous topics are available. So we've done, this is our 41st episode that we've done. So everything from ADOS, code-based diagnostics, component testing, forced induction, all that good stuff is available on our YouTube channel. Once again, youtube.com/Snap-on Diagnostics as well. Now it's time for Q&A, but before we do, of course, I got to mention my buddy Al, who also does diagnostics training, but he does scan tool specific diagnostic training. It is also free, and it is also on Zoom. So if you go to snapon.com/OT, you can register for those. Monday is Apollo, Wednesday is Zeus, Thursday is on Triton. So the first hour of the classes is going to be the same type of material, just on each individual tool. It's going to go through, let's set up your Wi-Fi, make sure that works. Going to go through, make sure that you get your free Snap-on Cloud account set up so you can share files with people. We're also going to go through code to completion, real world scenario on fast track intelligent diagnostics, let you know all the ins and outs, how that's going to help you diagnose cars faster, no matter what kind of tech you are. That's about an hour. And then on Wednesday and Thursday, since the Zeus and Triton also have component tests and meter functions, he goes through, after about a 5-minute break of the first hour, goes through another hour on all the scope and meter functions. So if you ever wanted to learn more about that, this is definitely the place to go. So Al is a deep well of knowledge when it comes to Snap-on Diagnostics. He's been with us since the beginning. And definitely make sure you check that out, snapon.com/OT. All right, so let's see. I got a couple on Zoom. Pete says, thank you. Thank you, Pete. Thanks for watching. Let's see. David Lemke, humidity also contributes to temps as well. Yes, so the different relative humidity will affect how well that air conditioner is operating, because we didn't really mention it, but on really humid days, that air conditioner also pulls a lot of water out of the atmosphere as well. That's why you have the drain tube down the bottom of the thing. Let's see. Thomas, thanks for that. Let's see. Andrew, I'll get to your question in a minute. Let me get to the rest of the questions that pertain to this class first. Let's see. M. Noman G, thanks for this. Thanks for coming. Shifting Gears, welcome back from Utah. You check in all the way. Every week, always good. Aficionado, good afternoon. Hey, checking in from the UAE. Welcome. Thanks for that. Winston, welcome. Aiden, good afternoon. Let's see. Leopold. Let's see. Should be lower pressure. Should be high pressure liquid at the evaporator. And that's going to be a little bit lower pressure because of that expansion block. Abel, thanks. Welcome from Phoenix. Yeah, weather is 91 degrees. It's wonderful. If you like warm, right? Abel says, how can I check the compressor with the power probe? So I guess a couple ways you could do it is, if it's not getting voltage, you can check the clutch. I'm assuming you have the power probe that you can provide 12 volts to it or provide ground to it. So you can check the power side, you can check the ground side with the power probe like that, if that's what you're referring to. Definitely could check the clutch. You can check it at the relay as well. Make sure that relay is working or not. Raymond, welcome. Thanks for checking in. Pro Volume, thank you. Glad you enjoyed it. Claude, when will this be posted for student viewing? It will be available pretty much as soon as class is over. I do edit it usually the next morning just to take out the intro clip, but other than that, it should be ready to watch within an hour usually. So Claude, the YouTube version anyways, it's always available right away. So with that, George says hello from Illinois, Wick Automotive. Thanks for joining us here as well. Always appreciate everybody saying hi, checking in, telling us where they're from, because that's always cool. We can see people from all over the world doing this, and I think that's one of the coolest things that we get to do with this is we can we can talk to people no matter where you're at in the world and no matter what time of day it is, because they can always watch the recording as well. Stephanie asks on Zoom, any tips on diagnosing evaporator leaks? Probably the best way I've found to do it is just have dye in the oil and then use a UV light. It's about the best way to do that, because it's kind of hard to get to most of the time. I know half the time when we were at Subaru, we had to pull the whole center stack and the whole dash apart to get the evaporator out. And then finally they came out with ones you could just slide out, but not for a while. So that was a pain to diagnose those problems. As far as maybe a clogged evaporator, you might be able to get in it with a thermal imager. Or if it's freezing up, that could be a thermal problem as well. So with that, hopefully I answered your question there, Stephanie. Thanks for asking. Let's see. Is the new update for Zeus? Yes, the new update for Zeus came out Monday. We don't put them all. Everybody doesn't get them at the same time. It's usually spread out over a week, just so we don't overload the server. So just keep checking ShopStream Updater on the bottom, and it came out Monday. So when it's your turn in line, then they will tell you it's ready with that. All right. So Andrew's got a question checking misfire on a 6-cylinder, a single ignition coil and distributor cowl. Let's see. Looking for a misfire on cylinder number 1. Not using guided component testing, using scope and meter. Let's see. So you want to be in ignition setting. So you can go into the ignition. I don't know what tool you have, but you may have an ignition scope if it's a Zeus or a Varus, or you can go into just ignition on a 2-channel like a Modus. Where do we put the RPM trigger lead? So you must have a Zeus or a Varus, or maybe even an older Modus that has the RPM trigger lead. So the RPM trigger lead goes on cylinder 1, and then the ignition probe goes on the cylinder 1 wire as well. And then you can just do single cylinder ignition. Now, if you have a distributor vehicle with a single coil like you're describing, I would probably put it on the coil wire and be able to compare all the cylinders all at once, put it in a parade format, and then check them all at once. If you want to see more about that, we do have some ignition testing videos that you can watch on that as well. So hopefully I answered your question on that, Andrew, as well. So with that, looks like we cleared the big boards. So hopefully picked up some timely tips and tricks on air conditioning, seeing as it is spring in the top part of the world. So with that, thank you for joining us. Hopefully we'll see you next week for motorcycle diagnostics. Thank you for your time, taking time out of your day to come spend with us. Definitely appreciate it. And with that, enjoy the rest of your week. Enjoy your night, whatever time of day it happens to be. See you next week. Take care.